Hello friends, this is Professor Dattu Patel from LJ Institute of Engineering and Technology. Today's session we are going to discuss about Cauchy-Euler's linear ordinary differential equation. First of all, a linear ordinary differential equations of nth order of the form x raised to n times derivation plus k1 x raised to n minus 1 d raised to n minus 1 y of dx of n minus 1 means n minus 1 times derivation and so on. K of n minus 1 into x divided by dx plus kn of y equal to r of x, where k1, k2, k3, k4 and so on are constant and r of x is any function of x is called Cauchy-Euler's linear ordinary differential equation. In this method, we first of all assume x equal to e raised to z, then taking logarithm both sides, then ln x equal to ln e raised to z. According to the properties of logarithm, we get z equal to ln x. Each and every example, we first of all assume x equal to e raised to z. Now, here y is a function of z and z is a function of x. Then y is a composite function of z by chain rule. Then we can write here our differential equation in terms of dy by dx equal to dy by dz into dz by dx. Clear? But here x equal to e raised to z first of all, then derivative of x raised to z with respect to x, that 1 z is a function of x, then e raised to z into dz by dx. Now e raised to simplify this term, then we get 1 upon e raised to z equal to dz by dx. Then e raised to z equal to x we can write, then dz by dx equal to 1 upon x, we can write this. Then substitute this value in this equation, then we get dy by dx equal to dy by dz into 1 upon dz by dx and 1 upon x. X comes this side, then to become the subject, dy by dz equal to x into dy by dx means x dy by dx equal to dy by dz. Here d by dz, then we can write theta, and d by dx, then we can write dx. Means here we can write x y dash as well as x dy, then we can write theta into y. That is the formula which is used in differential Cauchy-Euler's linear differential ordinary method. Similarly, means single times derivation into x, then we can write theta into y. First of all, how we can identify this differential equation is Cauchy-Euler's linear differential equation? Then here n times derivation, then must be multiplied with x raised to n. Here single times derivation, then multiply with x. Suppose differential equation y triple dash, then must be multiplied with x cube. Suppose y double dash, then must be multiplied with x square. Here constant term whatever, sign whatever, positive, negative, constant value, plus, minus, 2, 3, 4, whatever. But condition is required, if second or 2 times differentiation, then must be coefficient which is multiplied with x square, 3 times derivation, then x cube. Suppose single times derivation, then x and y equal to 0. This type of differential equation which is given in question, then we can say that is our Cauchy Euler's linear ordinary differential equation. Then at that case we can write theta into y. Similarly, you can suppose second order differential equation, third order differential equation. At that case means x square into y double dash means x square d square y by dx square. Then we can write theta minus 1 into y, x cube y triple dash. Then we can write theta minus 1, theta minus 2 into y. Suppose x raised to 4 by 4 times derivation. Then we can write theta minus 1, theta minus 2, theta minus 3 of y, and so on. Means where theta equal to d by dz. Clear? These are the formula we can use in examples. Here x into y dash, then we can write theta into y. Means our differential equation we convert in terms of z and solve the differential equation in terms of z, and then after we convert again in terms of x. Clear? Let us start with one example to better understanding. Example is x cube y triple dash plus 2x square y double dash plus 2y equal to 10 x plus 1 upon x. Then first of all we identified given differential equation is Cauchy Euler's or not. Then here 2 times differentiation, then must be multiplied with x square. Single times derivative term was not present. 3 times derivation, then must be x cube. Then we can say that given differential equation is Cauchy Euler's linear differential equation, means which is Cauchy Euler's linear ordinary differential equations. Clear? Then first of all we assume each and every example x equal to e raised to z, taking logarithm both sides. Then ln x equal to ln e raised to z, then according to the properties of z equal to ln x. Clear? Now here 3 times derivation, then we can write theta minus 1, theta minus 2 plus 2 as it is. 2 times derivation, then theta minus 1 plus 2 common y equal to 10. That is our r of x portion. Then we convert in terms of z, where theta equal to d by dz, then x equal to e raised to z, then 1 upon x equal to 1 upon e raised to z. Now expand this term. So first of all, theta square minus theta minus 2 plus 2 theta square minus 2 theta plus 2 equal to 10 e raised to z plus e raised to minus z. Again expand this bracket, then we get theta cube minus 2 theta minus theta square plus 2 theta plus 2 theta square minus 2 theta plus 2 equal to 10 e raised to z plus e raised to minus z. Now simplify this term. Now can this term are cancel out. The remaining term is theta cube minus theta square plus 2 of y equal to 10 e raised to z plus e raised to minus z. Then this term which is indicated by f of d and this term which is indicated by r of x. Now we find yc and yp according to this. Then first of all we find complementary function. Then our auxiliary equation is m cube minus m square plus 2 equal to 0. Then first substitute the values of factorize this term. Then we get m equal to 1 and 1 plus or minus I. Then our yc equal to c1 e raised to z. Here we write in terms of z because where theta equal to d by dz. Then that is a combination of case 1 and case 3. Here e raised to alpha z. Then alpha means 1 into z. c1 already used and c2 cos z plus c3 sin z. Where c1, c2, c3 are arbitrary constant. Then our yc, that is in terms of z. Then we convert in terms of x because our differential equation is dy by dx. Then e raised to z, then we replace as a x. Then c1x e raised to 1 into z, then z. Then again x, c2 cos z. Then we can write ln x plus c3 sin. Here write ln x. That is our equation number A. Clear? Now we find yp. Our formula is 1 upon f of d into r of x. Then in this method we use all these shortcut cases. That is depends on r of x. Case 1 to 5. Clear? Now we give the 1 upon theta cube minus theta square plus 2 e raised to z 10 constant plus 1 upon theta cube minus theta square plus 2 e raised to minus z. Here we use case 1 of shortcut method. Here 10. Now here a equal to 1, then denominator portion can't become 0. Then 1 minus 1 plus 2 e raised to z. Here that is minus 1. Then minus 1 plus 2, that is becomes 0. Then multiply with z and differentiate this term. Means 3 theta square minus 2 theta. Again we replace a equal to minus 1. Then here 10, 1 by 2 e raised to z plus z. Again we replace minus 1. Then 3 minus 1, then minus minus plus e raised to minus z. Then our tens comes inside. Then 5 e raised to z plus 3 plus 2, 5, 5 2 z. Then 2z e raised to minus 5z. That is our yp. Now we convert in terms of z. X. Then 5 e raised to z means x plus 2 z means ln x into 1 upon x. That is our yp. Now general solution is, that is nothing but the combination of complementary function and particular integral. Then substitute the values of yp and yc, means equation A and equation B at here, means c1x plus x, c2 cos ln x plus c3 sin ln x plus 5x plus 2 ln x 2 by x into ln x, where c1, c2, c3 are arbitrary constant. Let us understand one more example. Next example is x square y double dash minus 4x y dash plus 6y equal to 21x raised to minus 4. First of all, we identify that is Cauchy Euler's or not. Then 2 times derivation multiply with x square, single times derivation multiply with x. If triple times derivation is present and multiply with x square, then we can say that given differential equation is Cauchy Euler's, which is Cauchy Euler's linear ordinary differential equations. Then in this method, first of all, we assume x equal to e raised to z, taking logarithm both sides. This is Cauchy Euler's linear ordinary differential equation. In this method, we first of all assume x equal to e raised to z, then taking logarithm both sides means ln x equal to ln e raised to z. Then we get z equal to ln x. Now, in this method, 2 times differentiation. Then we replace theta minus 1 into y which is common, minus 4 as it is x into y. Then we get theta into y plus 6 y common, 21. Here x raised to minus 4. Then we can write e raised to minus 4z. Now expand this bracket, then theta square minus theta minus 4 theta plus 6 of y equal to 21 e raised to minus 4z. Then we get minus 5 theta plus 6 of y equal to 21 e raised to minus 4z. That is our f of d, and this portion that is our r of x. Then factorize this term. Then our auxiliary equation is m square minus 5m plus 6 equal to 0. Then 3 2s are 6. Then m square minus 3m plus 2m. Minus 2m plus 6 equal to 0. In this term, m common, then we get m minus 3, minus 2 common, that is m minus 3 equal to 0. Then we get m minus 3, m minus 2 equal to 0. Then m equal to 2 and 3. Then yc equal to c1 e raised to 2z plus c2 e raised to 3z. We require in terms of z. Then convert in terms of x. Then x equal to e raised to z. Then we can write here e raised to z whole square. Then e raised to z equal to x. Then x whole square. Then we can write x square. Then that is x square, and that is x cube. That is our equation number 1. That is our yc. Now we find yp. Then yp equal to formula 1 upon f of t into r of x. Substitute this value. Then 1 upon f of d, theta square minus 5 theta plus 6 into r of x, that is our 21 e raised to minus 4z. In this term, we use case 1. But each and every example, we use different cases of shortcut method. Suppose here sine or cos, then we use case 2. Suppose here in terms of z, z square, z cube, then we use case 3. E raised to x into z, e raised to z into sine, then we use case 4. That is depends on r of x. Whatever the case you can use depends on r of x. maybe case 1, 2, 3, 4 and 5. Clear? In this case, a equal to minus 1. Then substitute the values where theta equal to. Then minus 4 whole square. Then minus 16 minus 4 minus 5 into minus 4 plus 6 e raised to minus 4z. Then we get plus 20 plus 6 e raised to minus 4z. Then 20 so on so forth. Then 42 e raised to minus 4z. Then convert in terms of x. Then here x raised to minus, that is our yp. Then last equation, that is nothing but the combination of yc and yp, that is our general solution. Then general solution is y of x equal to yc plus yp. Then substitute the values of yc, that is c1x square plus c2x cube plus 1 by 42 x raised to minus 4. Clear? That is our general solution. Now similarly, x square y double dash minus 4x y dash. So this example already solved. Y double dash plus 1 upon x y dash equal to 12 log x upon x square. This example cannot in form of Cauchy-Euler's differential equation. But first of all, we convert in terms of Cauchy-Euler's, then multiply with x square, then x square y double dash plus x y dash equal to 12 log x. Then this equation, which is Cauchy-Euler ordinary linear differential equation, then this x square comes this side and multiply each and every term with x square. Then that equation convert in terms of Cauchy-Euler's form. Then you can easily solve here log x or ln of. Then we can write z. Then here 12z. Then we use case 3, that is binomial expansion. Next example. X square y double dash minus x y dash plus y equal to sine log x. Here in terms of function is sine. Then here ln x equal to z. Then it becomes sine z. Then in this example, here we use case 3. Here we use case 2. Sine z. Then we use case 2. In this case, this square equal to minus. Replace this square equal to minus a square. Next example. X square y double dash plus 4x y dash plus 2y equal to x square sine log x. And in this example, here r of x equal to e raised to z, that e raised to 2z into sine z. Then we use case 4. Then each and every case, try yourself. These examples as a homework. Try yourself to solve the differential equations. If you have any doubts regarding this topic, then feel free contact me. Thank you so much for listening these videos.